Why can the same idea cause different number of tokens? Let's find out. Look at this. English says, "How are you?" and the tokenizer can represent it in just 4 tokens. Hindi says the exact same thing, but can take 6 or more. Same meaning, similar sentence, completely different token cost. And this isn't just a language curiosity. It can affect how much context, compute, and money your AI usage consumes. So, how do we actually measure this? That's where token fertility comes in. It's basically tokens divided by words. For example, 4 words becoming 5 tokens gives us a fertility of 1.25. The lower the number, the more compact the representation. The higher it gets, the more fragmented the text becomes. But here's the real question. Why does this happen? Tokenizers don't have a perfect token for every possible word. They learn patterns from their training data. Frequent patterns can become large, reusable tokens. Rare patterns, they get broken down into smaller subword pieces. And that's the secret behind BPE style tokenization. Here's a perfect example. We look at computer and see one word. A tokenizer can represent that as one token, but give it something rare or unfamiliar, and suddenly one word can explode into multiple pieces. That's because the tokenizer isn't thinking about meaning, it's looking for patterns it already knows. Now, let's take this idea one step further. Imagine the exact same sentence across different languages. The meaning stays the same, but the token count can change dramatically. 4 tokens here, 6 there, 8 somewhere else. Why? The tokenizer's vocabulary comes from its training data. Same meaning doesn't guarantee the same token cost. And now you are probably thinking, okay, so what? Well, those extra tokens have to go somewhere. More tokens consume more of your context window. They require more computation, and depending on the model and pricing, they can increase your API cost too. So, token fertility isn't just a technical metric, it can directly affect AI efficiency. And here's where it gets even more interesting. This isn't only about languages. Code can become token heavy, numbers can fragment, emojis can take multiple tokens, rare words can get broken into subwords. So, token fertility depends on what you are giving the tokenizer, not simply which language you are using. But there's one very important distinction. Higher fertility does not mean a language is bad or insufficient. It means that this particular tokenizer represents this particular text less compactly. Change the tokenizer and the result can change. So, fertility is a property of the text tokenizer interaction, not a score for the language itself. Now, let's zoom out and look at the entire pipeline. Then comes the tokenizer. It converts your text into tokens. Those tokens go into the LLM, and eventually you get your response. So, before the model can even work with your sentence, the tokenizer has already decided how that information will be represented. And that's the big idea. We don't want more tokens just for the sake of having more tokens. We want a compact representation that preserves useful information. Better tokenization can mean better use of context and more efficient processing. So don't just count tokens, understand what those tokens are doing. And that's token fertility. Next time an AI model gives you a token count, remember, those tokens aren't just numbers. They determine how efficiently your information gets represented and processed. If you learned something new, hit like button, subscribe for more such video, and I'll see you in the next one.